Yeah, I think it's all set. So today we're gonna have a special seminar based on a cross or joint between ECOP and this dive seminar series. And our speaker today is Professor Mitchell Harley, and he's from School of Civil and Environmental Engineering, University of New South Wales, Sydney. Correct. His background is in physical oceanography and also environmental engineer as well. So today, let me introduce myself too. I'm Tachanat from Burapha University. I'm based on Janburi campus in the eastern coast of Thailand. And today we also have two moderators. One is Dr. Pavita Bunrat from Faculty of Technology and Environment, Prince of Songkhla University, Phuket campus. Right? Her expertise also involved with optics, remote sensing, and also environmental technology. And another moderator will be show up in a minute. Dr. Goroon from Faculty of Science, Kasetsat University. She also involved with many areas of community engagement in marine and coastal resources restoration. Yep. So today it's quite exciting that we're gonna have a talk about CoastSnap. So initially, could you explain us like what initially motivate you to develop CoastSnap at the beginning?
Well, what initiated me? Well, I'm interested in how coastlines change. I'm also interested in photography, and I like to take photos of the beach. And in Australia, we have lots of beautiful beaches like you do in Thailand. And every time I go to the beach, I notice that it changes. And during my PhD, I was working on some technology to use photos to turn it into actual measurements. And that's how the idea of CoastSnap began, in that we all have smartphones. And so taking a photo of the beach and turning that into measurements, I could, as a scientist, start to think about what we can actually do with this data and use that data, all those photos that are coming from social media.
How long do you develop this, or you brought this idea into real application that show up now?
It started in 2017. So now CoastSnap has been going for 8 years now. So we started on the northern beaches of Sydney, and since then it's just grown and grown, and now we have over 8 years of measurement, so it starts to have a really good data set of changes all around the world. Yeah, I can explain maybe in the presentation. Should I?
Okay.
Yeah.
Please.
Yeah, I'll share my presentation.
Share your screen. Yeah.
Yeah. Okay, let me just bring that up. Yeah, so as I was saying, yeah, thanks very much for inviting me. It's really a pleasure to be able to speak to this community. My name is Mitchell Harley. I'm at the University of New South Wales in Sydney, Australia. I'm at a place called the Water Research Laboratory. It's currently 10 p.m. here and a lot colder than I think in Thailand. I'm actually wearing my jacket. I see everyone in t-shirts, but it's a lot colder here. I am a coastal researcher, as I was saying, and I study how coastlines change. And today I'm going to be talking about the project that I founded in 2017, 8 years ago, as I said, called CoastSnap, and a global citizen science project to monitor changing coastlines. So in Australia, and most coastlines are very dynamic. And what I'm going to show you, just to give you an example of how dynamic coastlines are, I'm going to show you just this one video that we have from a beach in Sydney. We study how coastlines change, and we use a lot of cameras to measure that. And we have one camera in Sydney which has been taking photos every 30 minutes for the past 25 years. So an amazing data set. And it's particularly interesting during storm events. So I'll show you this video. This is 4 days of changes from this camera, just to show you. This is at the beach before the storm. And then we have a big storm arrive. In Sydney, we can get waves that exceed 8 meters, very big storm events. And you can see just in a few days that the beach can completely disappear. So it goes from a very wide beach to a very eroded beach with houses. And you can see if just here this swimming pool, which collapsed onto the sand and caused a lot of damage. So what we are interested in is studying how the impacts of these big extreme storm events and how they change along a coastline. Another thing to point out, though, is that coastlines are very resilient. So this was the photo from that camera taken just after the storm. You can see the erosion, but have a look at the beach 1 year later. So that's what it looks like 1 year later. The sand does come back, and that is all natural. So natural beach recovery. There's no trucks or anything bringing that sand. That's completely natural beach recovery. So beaches, yes, they can erode a lot, but then the sand generally does return, and so they're very resilient features. But coastlines around the world, as we all know, are under threat. So there's a lot of pressures that are facing coastlines. The first, obviously, is with sea level rise. Sea levels are rising and have been rising for some time and are going to accelerate in how much they rise. There's obviously issues with coastal pollution, both macroplastic and microplastic and other chemicals. Overdevelopment, so a lot of pressures placed on too much housing being put close to the coast. We have extreme storm, as we saw in that example, and the erosion that can cause from that is extreme storms, but also over the longer term. And then also habitat destruction for things like coral reefs and marine heat waves and things like that. So coastlines are under threat from a whole lot of different aspects. And so we need to come up with better ways to firstly monitor their changes, and so we can better manage them. And that is where CoastSnap comes into the picture. So CoastSnap is a very simple idea. It is essentially just a piece of stainless steel, this camera cradle here that we install on the beach. And it's like a tripod for your smartphone. So you place your smartphone into the tripod, take a photo, and because the tripod is always in the same position and angle, over time we can use all of the photos taken from that station to track how the coastline is changing. And we have some information on the station to show how people can upload. So it's a very simple idea, but it's very effective because it's harnessing the power of the community, and it also promotes education and interest in our dynamic coast. But it's also very important to get data to monitor beach health and coastal change. So these are very simple ideas. It's very low cost. This is what the sign looks like that we install. So it's basically, we have a QR code on each station, and all the community needs to do is take a photo in the cradle and scan the QR code, and that goes directly to a link to upload the photo. So within 1 minute, a community member can become a citizen scientist and actually contribute data to a coastal monitoring program, which is quite amazing. No training needed, just 1 minute, and they can become a citizen scientist. So very simple, very low cost, but also very powerful. So this is an example of one of our stations. This was our second station that was installed at North Narrabeen Beach in Sydney. What I'll show you is that we can actually use the data, the images, to actually measure changes to the coastline quite accurately using a technique known as photogrammetry. And I'll explain a little bit more about that later, but this is a video of 1 year of changes. Now, it may not look very good on the live stream, but you can see this on YouTube later. But 1 year of changes, and you can see a big storm event causing erosion, so the beach getting narrow, but then coming back again. So, and you can see all these changes to the entrance to, this is a coastal inlet, and how it opens during big storms, but also then closes again from time to time. All of this data taken by the community. So that's just one example of one station over 1 year. But the really powerful thing about CoastSnap is it's not just about the images, but we can also get data from it. And it's very amazing. The impressive thing about CoastSnap is that it uses a technique, as I said, called photogrammetry, and you have these photos here, and using this equation, and I'm not going to go too much into the mathematics, but it actually, from each photo, we can rearrange the pixels so that the photo looks like it was taken from space. And we do that by using information in the photo called ground control points. And so this is the same photo, this photo on the left and the right, but the pixels have been rearranged to as though it was taken from space. And these are the ground control points. So these red circles are basically points in the image that we actually know the coordinates of, and we tend to look for fixed locations. And then we can from that we can actually do that conversion. We can also use that in natural settings, so we don't need just corners of buildings, but we can also do that from even a natural beach where there's no buildings or anything. So this is myself walking around the image with a GPS taking points. And from that, we can actually merge the image into a composite image as it looks like here. And we can actually use these points in the image as ground control points. And then we also use what's called virtual ground control points, where we're actually taking features like distant mountains and things like that to control the image. And of course, we measure the location of the cradle as well using a GPS. So the way that once we're in that framework where we've converted the image to a top view, we can then, as coastal scientists, we're very much interested in the position of the shoreline and how that changes. And so so this position of the shoreline you can see in red, and it's basically the interface between sand and water. And we detect that shoreline using an algorithm which looks at the colors of the sand and the colors of the water. Most of the sand has a lot of red in it, and water tends to be blue. So we use those differences in the color channels to detect the shoreline. And then importantly, we also take into account the tide levels and the wave conditions at the time of the photo, because each photo has a timestamp, and from that we can actually compare that time of the photo with a nearby tide gauge and the water level and the wave conditions, and then use that to actually estimate the elevation position of that shoreline. So that's how we can turn the photos taken from the community into into data and specifically shoreline positions. Just having trouble. Okay, sorry, I just wasn't switching. So we measure the shoreline with the difference between the red minus blue. Now, through this photogrammetry technique, one of the cool things that we can do is that we can actually, without you telling us what smartphone you use, we can actually determine it just through the ground control points and the geometry of the camera. And so when we were doing these experiments in the pilot project, we could actually see that, well, a lot of phones were actually iPhones, and at the time it was iPhone 5, iPhone 7. And we could actually see that just without the people telling us what model smartphone they had, which was pretty cool. And we've done some comparisons between CoastSnap and in situ measurements, so actually walking along the beach with a GPS. And you can find these results published in Coastal Engineering Journal. And what we find was the shoreline accuracy tends to be about 2 to 4 meters in the horizontal. So when we have big storm events, that the amount of erosion can be in the order of 50 meters, an accuracy of 2 to 4 meters is more than acceptable, particularly considering that it's essentially very cost-efficient data. So why CoastSnap in particular? What are the benefits? Firstly, the community is directly participating in coastal science. So that's quite a really important thing, particularly when communities are ultimately who are going to be affected by the decisions made on the coast. So it's really nice that the community is actually the people who are collecting the data to affect those which is affecting the decision-making process. So it's essentially closing the loop of the decision-making cycle. It's cost-effective or low cost. It's simply a piece of stainless steel which can be manufactured locally and quite cheaply. Certainly a lot cheaper than a video camera or other technologies. It's very easy to roll out, so we can install them very quickly and at scale. Local authorities, state and local councils is very, very appealing because it does monitoring, but it also involves the community. It creates a powerful visual record of coastal change through these time-lapse movies. So you can go back and look at the images, and images are very powerful communication tools just by themselves. So it creates this good visual record, but also, as I said, it creates quantitative data through these advanced photogrammetry techniques. And I'll actually show you an example of how we do that. I'll step you through in real time. I'll give you an example of that process. One of the good things, because often people ask, well, why don't we just use satellites? Yes, satellites are really good, and you can see the Landsat satellite here. Well, because these are ground-based measurements, they're actually not affected by cloud coverage. Cloud coverage, particularly in tropical areas, is as I'm sure you are aware, can be a huge problem. But we can actually see with CoastSnap under the cloud, so you're getting data on the ground. I think it's fun and engaging, and anyone can do it. As I said, it just takes 1 or 2 minutes for people to learn and contribute. And then it also can be incorporated into education programs to help get communities involved, get community groups, get school groups, any group that may be interested in learning more about the coast. It's a very simple way to get them involved with data collection. So what I may show you now is actually, I'll try to do this in real time, just to show we actually have a software just to do this process. So let me see if I can see if this will work or not. So this is always a risky thing that it may not work, but let's just try. So we have software which is available online, and this is written in MATLAB, and we have a graphical user interface. So basically we load an image. Let's choose an image. This is from our Manly station, which is close to where I am. Let me find one.
My life is also rely on MATLAB too.
Yes, I'm a bit embarrassed showing MATLAB, but and not Python. So here's our image. This was taken last month at Manly by the community, and we have it on the left. And then we can just click the rectify image button. Oops. And so what we do is we need to click on the images, the ground control points. So these corners of solar panels here on the roof, we basically need to tell the software where they are in the image. Now, we have different points. So this pipe here, this corner of the building here, we try to get points that are distributed around the image. So there's this building in the distance, and then this corner of the staircase here. And another corner. And then once I've finished that, so there's 7 points in this particular example, it's going to try and calculate all the properties of the photo, and there it does that conversion. And so you can see on the right it's the exact same image, but it's been all the pixels have been rearranged so as though it's taken from space. Now, one thing that we can do then is, let me see if I can bring that up. So I don't know if people use QGIS at all, but that image that we just had, we can actually drag into there. I think we have to set the layer. And there it is. So that photo taken by the community is essentially being converted into a satellite photo. That's the first step in the process. And then,
sorry, since when did you tell like the GPS of each point, or the software just does it for you?
So in the background, I've got a what you have to do is there's a database. It's very simple. It's just in Excel, and in that database, once it loads, it has you can see here it has all of the coordinates of each point. So we have to create this Excel database where we actually have the coordinates, and that's how it communicates with the software.
Oh, that's from the lock platform, right? The position of the platform.
Yeah, so you do have to go out to set it up. You have to go and measure some points, and then once you've done that, you put this in the Excel spreadsheet like so, and then you can start doing that and do the conversion straight away. So not too complex. So all of that software is available on GitHub if you want to play around. I have tutorials on YouTube where you can play along with it and try to do it yourself. If you like MATLAB, I'm sorry, we're releasing a Python version soon, but it's not quite finished. So you're welcome to try to do that.
Nice.
I did my whole PhD in MATLAB as well, so
Okay. Yes, you can see there's a certain age where people did, well, I did MATLAB and then others switched to Python, but yes, now all my students are doing Python. So you can see it's a very simple idea, but because it's so simple, it's expanded quite rapidly over the last 8 years. In fact, this map is actually out of date. So we now have over 600 CoastSnap stations in 36 countries. So because it's very simple to implement, we're very happy to collaborate with people. But one big thing is that I don't see any red dots in Thailand yet. So we need to fix that. So
Yeah,
if
we
anyone,
hope so, yeah, at Phuket, right?
yes.
yeah, in Songkhla itself. I'm actually originally from Songkhla,
Okay.
and there's like this coast, like 5 minutes walk from my house, is it's like it changed constantly, and the government try to, I don't know what they're trying to do, but I can see that in the past 10 years they tried so hard to restore and protect the coastline. But this would be so useful.
Yes. So
What brought you successful implementation in South America, like Brazil or Argentina?
well, in those countries, well, I went to visit there and started working with some universities there, and then they started to build a network themselves, and so it was becoming very popular. I think Brazilians and Argentinians and from Chile as well, they all go to the beach a lot, and it's very, a lot of volunteers willing to contribute, so it's been very popular there. Also, as you can see in Europe, it's a lot of sites, North America, and also a few sites now in Africa as well, particularly in Ghana, which has been wonderful. So here's some photos of just the different sites around the world. And the way it works is basically people email me, and we have a starter pack where we give the designs and the sign templates and things like that, and then we let people manufacture the stations themselves. So people come up with different designs depending on the local resources. We don't manufacture the cradles ourselves for all around the world. People do it themselves because it's more cost effective that way. And that way you're also using local manufacturers. So you just need a welding company essentially to weld the cradles, and signs are quite easy to print. So lots of stations around the world. We also have a CoastSnap app, which we implemented in 2021, and that's a really good way to see all of the images around the world in real time. And we have things like a leaderboard, which creates some friendly competition between sites and between users. There's also an offline mode for remote sites. So all the images are Creative Commons 0, so people can use them as they want. And if you go to coastsnap.com, you can see what that looks like. Maybe I'll just show you. Where's my... Oh. So you can see the website. This is the map all around the world. And in real time, you can see all the images coming in. So here we have, just a couple of minutes ago, photos taken from Denmark, from Australia, from Spain. So all around the world, all these photos. But as I said, we don't have Thailand quite yet. So it'd be really good to see Thailand, but also in other parts of Southeast Asia.
From those of the picture you show us, it look like the beach all of the beach look so quiet. So comparing with the beach in Thailand, most of our beach are crowded. So does the number of the people or the use of the beach will affect the quality of the data or the analysis of the data?
Well, obviously with CoastSnap, because it's citizen science, you need people to take photos, but you don't need to always choose the most popular beaches where there's lots of people. In fact, a lot of these locations, as you can see, there's not a lot of people, but there's people who go on their daily walk. It only needs one person who is really passionate to take photos. And often what we call them local champions. So if there's one or two people or a community group and they go to the beach quite often, and they can be the people responsible for the station. And so they're often the best people to take photos. In terms of having people on the beach, does that affect the algorithm? Not really. We can still look at the shoreline, even though there's people on the beach. You can get a few little problems, but you can also use CoastSnap to actually look at changes in how many people are actually going to the beach. It's not just shorelines that we actually look at. There's a lot of different applications that we are using CoastSnap for now.
Sorry, how high up you need to install the station? Because I can see the angle of the shoreline is you got to be a bit high up so you can see yeah.
So if you see these examples here, obviously the higher the better. The higher up, like in this example here, this is relatively high once it loads. But so this station here is about 30 meters above. So it's a bit slow to load. 30 meters above sea level. You can see all the photos here. There it is. But we also have stations which are a lot lower. So where's another example? So this station here, for instance, this is right on the beach. This is only a few meters above the dunes. So it doesn't matter if you don't have a high point. All it does is affect how much beach you can measure. So if you have a higher location, you can actually measure about 1 kilometer or 2 kilometers sometimes of beach. For a lower location like this, you can maybe only measure a few hundred meters, maybe 400 meters of beach before it becomes too distant. So yes, it's better to have high elevation, but it's not. You can also have locations on low areas too, like jetties and wharfs. We use them quite a bit. They're very good. You can see all of the photos. Generally, we try to position it so it looks along the beach, and that is deliberate, because it's better for tracking changes to the shoreline when we are looking along the coastline. So that's one thing we do try to do when we are positioning the locations. So we have the CoastSnap app, but on the CoastSnap app, we also have one other thing. We also have a do-it-yourself option. So you don't actually need the station, but you can also just, if you have a corner of a post or something that can control the position, you can actually use that as well to upload photos. And in fact, if you go to Thailand on the app, there's actually people who have actually uploaded photos in Thailand. Let me go. So you can see there are some photos around the place. Where people have actually uploaded photos.
I
So
can see some in near Phuket.
yeah, I don't know where is this? So someone's uploaded some photos here. And so there is the option also to just contribute, get the community contribute onto the app, and do it yourself photos as well.
Do we also need to know like exact sea level, like into decimal places, or
To do the photogrammetry, yes. So you need to know the tide level. But sometimes you can get that from, there are these models that you can use now which can get the tide level at any location around the world. So you can do it that way. And here's an example of a do-it-yourself station where somebody was taking lots of photos at the one location, and you can get these really incredible videos from that of the changes, just from do it yourself without even using the cradle. So that's quite nice. Yeah, so we have the CoastSnap.com images over, well, it's actually over almost 100,000 images on that app now, which is it's becoming a really good database. And some of the things you can see, like this was one particular rain event where you can see some flooding. And then we can actually use it. I didn't show, but we can actually use the technology to measure changes. So when I go back, let me just, so it can map the shoreline. Let me just fix it. So this software maps the shoreline, and sometimes we just need to fix a few little points here. And then we save it. Save the shoreline. And then what we can do is we can actually go and look at the changes from that shoreline to another shoreline. So let's see if this works. Yeah, so here's just shoreline change looking at two different shorelines. So this is looking at basically 1 year difference. So you can see here the shoreline 1 year ago in blue, and then the present shoreline, and you can see it's changed for that particular example 4 meters. Sometimes you can compare it to different times. Let's see. Yeah, so here, this is a different time, and there's been 13 meters of change for that particular example. So you can go back and use it to create all of these information graphics about how it's changing. I'll just show you one more thing. If I go to CoastSnap. So we do create these reports. And let me show you this one. So this is what we create for councils, local governments. We create a summary report, and you can see, oops. We have a participation summary, so you can see how many photos have been taken and the leaderboard for that particular site. So at this site, we've had almost 1,000 photos, and you can see how it's changed at a certain, we've had an increase in participation. You can see the popular times of the day, day of the week. Sunday is the most popular at this site at 11 a.m. And then we get these reports of the shoreline changes. So you can see here, we had at this particular site, we had a really big storm event. And so you can see in this time series that the beach has eroded at this particular location. It went from, I think, a position of 91 meters wide to 26 meters. So what's that? Yeah, 65 meters or something of change. So quite impressive changes at that particular location. And then we provide, here we can some summary images of the changes. This is what the beach looked like when it was very wide. And then this was the beach after a storm. So quite dramatic changes. And then we also provide changes over the last 12 months and then of all time. So this station has been there for about 3 years. And so we can see the changes over 3 years with this big storm event right at the end, causing quite dramatic changes. And then we have additional information. So you can just simply go to the website and see all the photos from that particular location and download them all as you want. So that's essentially CoastSnap. It's a very simple idea, but very powerful. I should also point out there's some other things. It's not just shoreline change that we're using it for now. One of the things we're doing is we're using all of the photos to train algorithms for artificial intelligence. So we have a project with Surf Lifesaving Australia to actually detect rip currents from smartphones. And so we're training all of the images that we've collected from CoastSnap to feed a rip current detection. And so that's really exciting work. And another thing we're using a lot of AI things now. So we look at marine archaeology, so shipwrecks that are buried in the ocean, in the sand. We also there's some sites in Mexico and the Caribbean where there's a huge issue let me see if I can bring that up, is sargassum seaweed.
Mm-hmm.
I'm not sure if that's an issue at all in Thailand, but it's certainly...
Yeah, we have sargassum in Thailand.
Yes, okay. So for instance, where are we?
Sorry, what's that? What is a kind of seaweed?
Yeah, the seaweed that have a long rhizome.
Yeah, so
it's a good thing if we have them, right?
no, can you see here?
Okay, probably not so good.
Yeah, so it's a huge issue in a lot of countries that it arrives in really large numbers and causes really big problems for tourism, but also for fishing and things like that. So we're actually using the CoastSnap images to actually track how that is coming and going over time as well. So lots of different things, but the important thing is that you get the stations and start collecting images so you can actually start to get that long-term record of changes. That's the really important thing.
Sorry, you mentioned AI. Have you applied the recent kind of like AI algorithm in analyzing the images?
Yeah, so in a few ways. So as I mentioned, we're using AI for rip current detection.
Mm-hmm.
So training object detection algorithms. So that's, but not just rip currents, but also detecting other objects as well. So looking at changes in vegetation. We use it for counting people on the beach. See how many people are on the beach. We also used algorithms like Meta's segment anything. So that process I showed you about identifying the shoreline, that's using just standard photogrammetry techniques or remote sensing techniques. And that probably works about 80 to 90%, but I think with AI we can almost get that to completely automated to detect the shoreline. So we're starting to even use that a lot in our work to make it even more automatic.
When you first launched this approach, did you need to like implement education outreach for certain groups, like high school student or any certain kind of population that you target initially?
Initially, we just went to did community seminars, and we actually didn't do much. Actually, we just put the signs there, and we weren't sure on how many. But in Australia, I think people are quite passionate about the beach and going to the beach and taking photos. So it didn't actually need that much, but we're trying to do that a lot more now by working with community groups, school groups, and having more resources to do that. It's something that I'd like to do a lot more. So actually having groups to do that. In Brazil, they're doing that a lot. So they're going out and working with schools, and they're so it's really there's a lot that we can do, I think, with that a lot more.
In Thailand, the platform and the stand could be gone in a day. Like
Okay. Well, look, as I said, if that's an issue, and it's also an issue in many locations, you can also just have not even just the stand or the platform, it can just have the DIY. And sometimes we just have stickers. So you just have a sticker with the QR code and say, take photo from here. And even if the sticker gets removed, it's very cheap to put it. You just print 500 stickers, and so you just keep putting them on. And it's even that's fine. Or you can just work with the community, and you don't even need the stand. You just teach them, always go to this location and take a photo here.
The beach I mentioned in my hometown, I can see exactly where to put that, like the stand high up the beach, and it's in the temple, so no one will steal it in the temple. Like we will have a lot of guarding around that area. So yeah.
Maybe you can get the monks to take photos.
Those who destroy gonna get a cursed.
Yeah, they're not gonna go to heaven after.
I like this idea. In Thailand, we have the cremation place that the chimney is quite high.
Okay. Well, I've never thought about putting it on a cremation location, but
it works. It would work. People are not gonna want to be haunted, so no one will steal anything.
Yes.
Because today I discussed with Navy about this project too, because my workplace I do the project with the Navy in Chonburi under the Princess Sirinthorn project. So it's also possible to put it near the Navy place that can also protect from steal from people or the fishermen from stealing our tools.
Yes.
Some question from live video. They ask like in case of extremely oblique for photographs, how you rectify orthogonal points.
So as I said, when they're very oblique and the elevation is not very high, the rectification is not as good. So what happens is the pixels very quickly, they get very spread out. You know, the pixel footprint, what we call it, can be very large. And what that means is basically the coverage that we can measure is less. So normally for very oblique imagery, we can probably only measure a shoreline of about 200 or 300 meters. But that's okay still. You can still get for that particular location close to the camera, you can actually look at the changes just there. You just cannot cover like a large section like we have in other sites.
Back to the GPS survey, how many time that we need to do this GPS survey on this
Well,
work?
If the cradle doesn't move, you only have to do it one time. Yeah. As long as you have ground control points that are fixed, and like a house or something that's not going to move, then you only need to do it one time.
But with the DIY, it's gonna be more, we need to do it every time, right?
No, with the DIY, you have to measure, well, with the DIY, you have to measure the location of where you're taking the photo. So if you're measuring it on a top of I don't know, a post, you just have to measure the top of the post. It doesn't have to be accurate to millimeters. It can be accurate to about, I don't know, 10 centimeters or something. That's okay. But so that's why you use some kind of corner of something so that it's always the same. And what we are actually doing when we're clicking on the ground control points, we're actually calculating the angle of the camera and the rotation of the camera. So we're actually solving for that with the ground control points.
And how do the local tidal or wave data affect on the data on the
So the tide, we correct for the tide. So as I said, every single image we have
time?
we know the exact time, and then we look at that time and we can see the tide level at that location time. And so when we are doing the comparisons in the software, we only compare images taken from a similar tide level. Or we can correct for the tide by using trigonometry. But for the waves is a little bit more tricky. But what we tend to do is we do not measure the beach when there are big waves, basically. So we wait for calm conditions, and we just don't use the algorithm when there's a big storm or something like that.
You said you mentioned like you have a lot more to do with recurrence, and also can we estimate it, like sediment transport along the coast as well, in case we need to know like vertical changes in sand berm or whatever.
So we haven't tried that yet with CoastSnap, but with other techniques we can actually measure currents and how they're moving along the coast, but that requires video, so which is a different challenge when you're working with community photos, because you have to upload videos, and videos are a lot more heavy, and the community have to stay there for some time to collect the video. So we haven't tried that yet, but that's something that we're looking into. Another thing we're also looking at is actually measuring the bathymetry. So the bathymetry under the water. And so we do techniques where we actually collect video from the CoastSnap stations, and there are techniques where you're actually looking at how the wave celerity, so how fast the waves are moving, because that is directly how fast the waves are moving on the surface is proportional to the depth. And so if you measure the speed of the waves, you can actually estimate the depth of the water. And so we're actually do those techniques to get the bathymetry, which is quite interesting.
What is trade-off between cradle mount, CoastSnap station, and DIY, the DIY free roaming modes?
So the CoastSnap station are the ones where we have a cradle there, specifically there. The DIY ones are where there is no cradle, but people are trying to control for the location using a corner of something or some way to control it. The free roaming is just a photo of the beach with no control about the location. And so that's how we differentiate between them.
How many fans do you have? I mean, the fan club of the project.
The fan club. Well, we certainly have a lot of participants. So I think in terms of how many people have contributed, probably maybe 50,000 people have contributed photos to the project. So it's a really good community and all around the world. Yeah, I even saw in Thailand there was an influencer, a TikTok influencer in Thai, talking about CoastSnap one time, which was quite funny.
So, how the people in this community communicate to each other? Do they have their own community or platform on communication?
So you can communicate on the app. You can comment and write messages if you want. But in terms of the communities of CoastSnap, we have a CoastSnap user group. So we have workshops and we meet. We had a recent meeting in Spain in April, and so we try to communicate. Now we're having a setting up a Discord group so we can all communicate and share resources. So things when we're developing new tools like the Python toolbox, we can all share and things and share ideas, some education packages and things like that. So just to answer some questions.
Did you hear or have you heard like a success case from other country that this approach can contribute to like local administration or even policy level?
So I'm not sure in other countries, but in Australia, where there are some good examples of it actually contributing to decision making. So one of the things that one example I like is in one location, they actually have, it's an erosion hotspot, and they every once per year they have to dredge the beach and put sand on the beach. Now the company can only do that when the beach is very narrow, very eroded. They only have permission to do that when it's very eroded. And we're actually using CoastSnap to determine when the company can actually put sand on the beach. So the community takes the photos, and then you can see we measure the shoreline, and then if the beach is not wide enough, then it triggers, gives them the legal ability to actually dredge and put sand on the beach. So I think that's really nice that it's, the community's collecting the data for the decisions that are affecting the community.
Yeah, it would be cool to see what happened after they put sand on the beach as well. Like, what
Exactly.
is the change happen after?
Yes.
We have a question from a meeting chat. Shall I read it out?
Yes, please.
How of the policy of data sharing by request? For example, if people want to get for more analysis or future research.
Yeah, so as I said, all of the images are available for anyone. It's Creative Commons. So you can, on the website, there's a download images, and you can go to a site and download the images. We are trying to get better at actually also making the shorelines available, but we haven't got that ability yet. So we want to have a repository where you can also get the shoreline data. There have been some sites around the world, for instance, CoastSnap Spain, they have actually made a data paper where they actually, all of the shorelines that they collected from the project, they actually wrote it up into a publication and shared it onto a repository like Zenodo or something like that. So that's happening. But ideally, what I'd like to see is a central repository where you can access all sorts of data. But at least the images, if you go there, you can download the images and use them as you want.
Thanks so much.
I was thinking like we can start this pilot project in Thailand using like or design a portable stand.
Yeah.
And involved with high school students, high school clubs.
Yes.
Should be exciting for them.
Yeah, so we're actually thinking about, like, we've tried that, like having even a 3D printed stand with a, so it's just a stand, but you can actually just, like a clamp and just clamp it onto the same location. And so that can control and people just bring that stand with them and take the photos. So that's one option if you want to get the communities, high schools involved, and if you're worried about the stand going missing otherwise, yeah.
Sounds great, yeah.
Any other questions?
Because the method is so simple and so powerful, like you mentioned before. So are there any participant that included into the lesson or into the class for learning the beach or the coastal process, something like that?
To learn the coastal processes?
Yes.
Not yet. So I think we want to do some more of that. So as I said, in some locations in Brazil, they're doing that. They actually go to the classroom and they have like some like CoastSnap training, and like people can interact. They can look at the photo from today, and then they go to the photo from 1 year ago, and they can do an activity about talking about the changes and things like that. We'd like to do more of that, but we haven't quite done that yet. So I think there's a lot more to do with that.
One major issue in Thailand is they try to build hard construction like seawall around the beach to protect erosion, but in fact it's enhanced more erosion, or even it's destroy more in further areas.
Yes,
this is easy in Australia that people can invest or construct a hard seawall along the beach. or that's the last solution?
No, it happens in Australia too. But we always try to look for nature-based approaches where possible, like beach nourishment or other solutions. So yes, we try to make it the last option, but when there's people's houses and things that are being eroded, there's a lot of pressure to put on to protect those, which is always a challenge. It's a challenge everywhere, unfortunately. Yeah.
So what should we do? Like if we would like to start to make it the station in
Yep.
Thailand in the place that we ready for this project, how can
Yeah.
we start?
So basically, send me an email, and I have a CoastSnap starter kit, which has all of the links at how to get started, and then just go from there, really. So one thing, if you want to use the app, there is some challenges with license fees, but which we're trying to overcome those. But otherwise, if you want to just use your own system, you can use, any way that you want to submit the photos as well. Like other countries use WhatsApp or Gmail or, an email address or different ways to submit the photos as well. But we do have a starter kit that you can use.
Nice.
Have you got like other case that they use CoastSnap to monitor wildlife?
Wildlife? Not wildlife. Well, there's one example, and that's turtle nests. So in Australia, we have, turtle nests, and they actually use that to monitor that on the beach. So that's an interesting example. But and then vegetation, and as I said, sargassum, but that's the only wildlife that it's been used to date. Yeah. Lots of ideas though. Once you have the images, you can do a lot.
Yeah.
I also thinking about like
Green mammal.
we can study soundscape of the coast using video recording.
Yeah. I'll see if I can show you that example of rip currents, because that's quite interesting.
Oh yes, please.
I'll share my screen. Okay, this is very new work, so.
That's YOLO.
Yeah.
Yeah.
Great. That exciting.
See if that work.
It's
Yeah,
very
so
cool.
yeah, this is YOLO version 11. So yeah, so we can actually detect rips.
Oh, this on video, right? It's just the
Yeah.
snaps.
Yeah, so this is not actually CoastSnap. This is a new project we're doing. We're actually going to be working with Surf Lifesaving to actually collect video. We're going to use the same CoastSnap stations, but it's not CoastSnap. So that's another project with Surf Lifesaving Australia. But we've actually trained all of the images all of the data from CoastSnap photos. So because we have, as I said, we have over 100,000 photos, and quite a lot of them actually have rips in them. So we've actually manually gone through. Took a long time to digitize, annotate all of the rips.
That's very cool.
And
each beach you need to adjust you need to retrain the algorithm every time for different beach.
No, it's adaptive, domain adaptive algorithms.
Oh,
yeah.
wow.
So we've actually put together a really diverse data set of lots of different beaches, and because of that, it's very robust. And the idea is that you can go to a beach and point your smartphone at the beach and detect rip currents.
I see you have like many students working on rip currents for like master and PhD, right? Do you want some more from Thailand?
I was about to ask, like, how many people working in your lab? Like, it just seemed like an endless opportunity and ideas.
Yeah, well, I'm always looking for good PhD students. So if you want to send me an email with your CV, I'm always open to opportunities.
Guys who listen to this live, yeah, do it.
Yeah. So yeah, if you're a good student and you're excited and you're passionate and passionate about the coast, and yeah, we'd like to hear from you. Yeah, lots of different exciting projects. So yeah, rip current's a big one. So so rip current from smartphones. We're also doing rip current from satellites. Do a lot of work in early warning systems, so forecasting erosion. So knowing within, like, for the next 2 weeks, like coming up, being able to predict quite accurately where the erosion can occur, and then do a lot of work in wave climate and climate change as well. So all of those things.
Once you made CoastSnap successful, did you also have like more grants available?
Not really. I think the problem with CoastSnap is it's a low cost project. So one of the challenges is to fund it while also keep it attractive for people to install them. So we actually, in Australia, we actually sell CoastSnap as a kind of a bit of a business. So we sell them to councils, and we actually have a product where they can buy the post and shoreline monitoring, and they contribute to the project through that. So that's what funds a lot of the CoastSnap developments and things. But then we can, yeah, of course, now that you have this global network, you can leverage that for other projects as well. So it makes it, now we have this really powerful database of images. We can use that to train rip current detection algorithms and things like that. So that's really good platform to sell other ideas. Yeah.
All right. So thank you so much, Professor Mitchell Harley. So
you're welcome.
It's interesting talk about this approach to contribute like more or broader societal benefits. So
Yes.
And also thanks goes to two moderators, Dr. Goraon and Dr. Pavita. So we
You're most welcome.
gonna end up the live now, and please still stay here.